let's go to another example of recursion. So in this we have to reverse a string. So what we did in earlier example was, earlier problem was, we did not reverse the string was as it is, we just printed the reverse of string. But here we actually want to reverse a string. So you try to solve a problem and we will discuss the solution soon. So this particular problem can be solved in recursive as well as iterative way. It will be good if we try to solve both the approaches, because we'll have a comparison based on this after some time. So let's try to solve a problem. So whenever we have to reverse a string, what we do is we try to exchange the positions of element from first element and the last element, similarly second element and the second last element, similarly third element and the third last element, and similarly it goes like that. So let's say we have a index I. So the solution is to swap ith element from the n minus ith. We'll have -1 because the index is from 0 to n minus 1. So we want to swap ith element from n minus ith element. So ith element from the first and ith element from the last gets swapped or exchanged. I could be anything, it could be 0, 1, 2, depends upon the value. So in this case what happens is, as I said, we exchange first element from the beginning and first element from the last, similarly second from beginning, second from last. So what happens is, we can solve this problem by using iteration also and recursion also, and we will after this we will try to see that what are the differences between recursion and iteration, and in what cases why do we use, what are the disadvantages of using a recursion. So let's first try to solve it recursively, let's first try to solve it iteratively. So let's say we have a function reverse. This is another way of putting a parameter for string. So we take length of the string, we'll just go through it quickly, and we'll run a loop from I equal to 0 to n minus 2. Why? Because we don't want to, since we have already done the reverse, we want to happen only till mid element, because if we again go through to here, then the same, we'll get the same thing again, same string again, because the reverse swap will happen. We'll just simply write swap So this is the function for reversing a string iteratively. So what happens is I equal to 0 first. So these two elements get exchanged. Similarly, this gets exchanged, and this happens until we reach mid of the string. So okay, now let's try to solve this using recursion. So what happens in recursion is, as we said, that try to solve a sub problem that has similar code. So let's say first we try to, as a prep bytes as a string, we try to exchange first and the last position, and let's say now we have to reverse this particular thing. Again, the problem statement is same, that we have to reverse this string. So the problem is getting converted into sub problems. In order for prep bytes to get reversed, this rep byte should be reversed. Then again, for this to get reversed, we should epby, this thing should be reversed. So this is how sub problems are happening. So let's see how we can write code for this. I'm just writing this as swap. This is the code for exchanging two elements. In general, if you want to swap two elements, the code goes like this. Suppose you want to swap A and B, then we store the value of A in temp. So temp equal to A, and then we assign value of B to A. Then we put this A equal to B, and then we again do B equal to temp. So this is how we swap two elements. So this is what swap is all about. So what we do here is we swap stri minus, this is obviously from the last we have to swipe, sorry, so with this size minus I minus 1, and after we are done with this we have to do the swap inside this. So what we do, we call this function again. So we increment I because we need to remove these, because we need the reverse of ith to n minus ith element. So it goes like this, again str index plus 1 comma size. Okay, so as you can see we haven't written the base here. So what will be the base? The base will be, the base condition will be when this index, actually when it reaches here in the midpoint. As I said that it has to go only till this index reaches the midpoint of the this particular string. So when we say if index equals size by 2, we return. So this is how recursively it gets reversed. So what happens, let's try to understand. It's very simple. So we have a string, we increment the index. So what happens is, after we increment the index, these two elements get exchanged. Again these two elements have exchanged, we again increment the index to here. So this is the same thing that is happening in iteration. So as you can see that this code can be solved using recursion as well as iteration. So let's see that when we have a choice of doing recursion and iteration, what are the advantages of one over the other as well as disadvantages, and what are the similarities between the two. So let's discuss iteration versus recursion. So talking about the similarities, we know that both has to be terminated. So there has to be some termination condition, else they'll keep on executing infinitely. Second, they both include repetition. In case of iteration, the repetition is through loop, and in case of recursion, the repetition is through method calls, because we call the same method again and again. Now let's see what are the differences. So differences, or we can see this is the actually disadvantage of recursion over iteration, since recursion involves stack to store method calls, but there is no such need for in iteration. So what happens in stack is, recursion is, since stack is involved, we have recursion. Since stack is involved, recursion is slower than iteration. Since we have all the overhead of storing it in stack and removing it in stack, so this whole overhead thing actually makes recursion slower, and also recursion needs more memory than iteration. So we solved two problems till now. One was printing reverse of a string, another was reversing a string. Okay, one more very basic difference is that code of recursion is much simpler, because we are avoiding repetition of code, and iteration code goes much bigger. Since here we had small problem statements, so the code was small in both the cases, but as the complexity of problem grows, the recursive code is simpler to write. So we saw that we solved two problems. In case of print reverse, whatever we did there, we could have done it using iteration also. And in that case, for such small problems, it beneficial to use iteration, reason being it is faster and it uses less memory. Similar is the case with reverse. But there are cases when we have really complex problems and it's really difficult to use iteration over there. As we go forward, we will discuss about such problems. Now talking about application of recursion. Recursion has various applications. It has application in, it is used for backtracking. We will discuss these algos and concepts. Then we have divide and conquer algorithm. Then we can many of the trees question, or many of the, to solve problems of trees you need recursion. For graphs you need recursion. So as I said before also, that recursion has very wide application, and especially if you want to go with these concepts of backtracking, divide and conquer trees, graphs. So recursion should be something which should come natural to you, and you should be very good with recursion. And more problem you solve, you'll be getting better with recursion.